students, in the last video we discussed some proof techniques. In continuation to that, we will discuss some more proof techniques in this video. First technique which we will discuss in this video is proof by cases. Proof by cases is also known as proof by exhaustion. Why? Because our aim is to exhaust all the possibilities. In it, the problem is split into parts and then each part is considered separately. For example, here we have to prove that if n belongs to integer, then n square plus n is even. Now we will prove it by cases. First, if n is any integer, then n can be even or n can be odd. So we are considering that n is even. If n is even, then n will be equal to twice of k, where k is any integer. Calculating n square plus n, we will get 2k whole square plus 2k, which will be equal to 4k square plus 2k. Taking 2 as common, we will get 2k square plus k. Now this is any integer because k is an integer. Twice of any integer will also be equal to even number. So we have proved that if n is even, then n square plus n is even. Second case, if n is odd. If n is odd, then n will be equal to 2k plus 1 for some integer k. Now n square plus n will be equal to 2k plus 1 whole square plus 2k plus 1. Solving it, we will get 4k square plus 1 plus 4k plus 2k plus 1, which will be equal to twice of 2k square plus 3k plus 1. Again, it is an integer because k is any integer. Twice of integer is even, so we can say if n is odd, then n square plus n is a even number. Hence, we have proved that if n is an integer, then n square plus n is even. Next example, if an integer n is not divisible by 3, then prove that n square is equal to 3k plus 1 for some integer k. If n is not divisible by 3, then n can be equal to 3m plus 1 for any integer m. Now n square is equal to 3m plus 1 whole square, which will be equal to 9m square plus 1 plus 6m. Taking 3 as common, we will get 3m square plus 2m plus 1. This is an integer, let us assume it as k. So this is 3k plus 1. Second case, if n is equal to 3m plus 2, because n is not divisible by 3, so two cases are there, either n will be equal to 3m plus 1 or n equal to 3m plus 2. Then n square will be equal to 3m plus 2 whole square, which will be equal to 9m square plus 4 plus 6m. Taking 3 as common, we will get 3m square plus 2m plus 1 plus 1, because 4 is written as 3 plus 1. Again, it is an integer, let us assume it as k, so this is in the form of 3k plus 1. Hence, if n is not divisible by 3, then n square is equal to 3k plus 1 for any integer k. Next technique is proof by contradiction. When we want to prove any statement by contradiction, we assume that the statement we want to prove is false. Then we will show that this assumption will lead to contradiction. For example, we have to prove under root 2 plus under root 6 is less than under root 15. So we will assume opposite of it, that is under root 2 plus under root 6 is greater than equal to under root 15. Squaring both sides, we will get 2 plus 6 plus 2 under root 12 greater than equal to 15. 2 under root 12 greater than equal to 7. Again squaring, we will get 48 greater than equal to 49, which is a contradiction. So according to proof by contradiction, we can say that our assumption is wrong. So under root 2 plus under root 6 is less than under root 15. Next, let a be a rational number and b be irrational. then we have to prove that a plus b is also irrational. Now we will assume that a plus b is rational. Now a plus b can be written in the form of m by n, where m and n are integers. A is also rational, so a is equal to p by q, where p and q are integers. We know that b is equal to a plus b minus a. Substituting the value of a plus b and a, that is m by n and p by q, we will get m by n minus p by q. Solving it, we will get mq minus pm by qn. Now this term is integer, this term is also integer, because m and p, q all are integers. So integer by integer is a rational number. Hence we have proved that b is rational, which is a contradiction, because it is given that b is irrational. Hence our assumption is wrong. So we can say that a plus b is not rational, or it is irrational. Last technique which we will discuss today is proof by contrapositive. We know that for any conditional statement a implies b, its contrapositive is equal to negation b implies negation. So if we have to prove that a implies b is true, we will prove that negation b implies negation is true. Then according to proof by contrapositive, we can say that this is true. Example, let x is an integer, and if x square minus 6x plus 5 is even, then we have to prove that x is odd. So we will assume that x is even, because here a is this and b is this. We have to prove a implies b. So we will assume negation b, that is x is even. If x is even, then x is equal to 2a. Putting x is equal to 2a in this equation, we will get 2a whole square minus 6 into 2a plus 5. Solving it, we will get 4a square minus 12a plus 5. Taking 2 as common, we will get 2a square minus 6a plus 2 plus 1. This is an integer. Twice of integer will be even. Even plus 1 will be odd. So we have proved that x square minus 6x plus 5 is odd if x is even. So according to proof by contrapositive, we can say that if x square minus 6x plus 5 is even, then x is odd. Next example, if 3n plus 2 is an odd integer, then prove that n is odd. So a is 3n plus 2 is an odd integer, b is n is odd. So we will assume negation b, which is n is even. If n is even, then n will be equal to 2k. Now 3n plus 2 will be equal to 3 into 2k plus 2. It will be equal to 6k plus 2. That is 2 into 3k plus 1. It is integer because k is an integer. So twice of integer is even. So we can say that if n is even, then 3n plus 2 is also even. Hence, according to proof by contrapositive, we can say if 3n plus 2 is an odd integer, then n is odd. So that's all for this video. We have discussed proof by cases, proof by contrapositive, proof by contradiction. In the next video, we will discuss proof by induction. Thank you.